Oh, you don't have
I feel like all I need to do now is show images and videos. So I did actually bring the church. I've got a couple images of it. And I thought I would just speak a little bit autobiographically about what I thought the digital in architecture was for. And then I brought a whole bunch of stuff from the last 3 or 4 years that I think is really what the digital could be about now. So there are really two things that digital technology seemed important for me for like 20, I don't want to think, 25 years ago, 30 years ago. The first was that it was a tool to animate statics, and that I thought architecture was a field of statics, and that the best you could do would be to have a kind of Baroque attitude about architecture, where you would animate all the static components and therefore make a space which was very vibrant and had motion built into it. I mean, the same way that, that Panofsky would talk about Baroque space. The way you would do that, I thought, was through intricacy of tectonics. So every piece of a building should be intricately detailed and different, and it should be different in some kind of a pattern. And so the church was that. Every piece of steel in this carapace is a unique dimension. We had to draw every steel detail ourselves. Every panel is unique. And the idea is just that as you look at the surfaces, your eye flows along the surfaces and it becomes a very dynamic space. So I thought that was the best you could do with digital technology. I tried applying that to the scale of things like bricks. So with these blob walls and toy furniture, we would take, like this was one of my kids' toys, and we went on eBay and bought several hundred of them. And we would compose them all in a pattern where literally we would animate them to make a wall and then freeze that animation and turn that into a tool path and cut up each one of those things and assemble them. But I had a bit of an epiphany, I would say, 10 years in, and it actually came from Rolf Fellbaum, who's has been the CEO at Vitra for a very long time, and I consider to be one of the great mentors for design. He asked me to design a chair, and he said, why don't you bring 3 designs, because you're not going to get it right. He said, a chair's harder than a building. So I had the idea to bring in a chair that you would 3D print, where every piece of the chair would be unique. I had another idea of a steel chair which would be built out of more components than any chair ever built before. That was my idea. And then I had another one that was built just out of 2 surfaces. And I showed him all 3, and he stopped at the one that was built out of more pieces than any chair, where every piece was different, and he said, okay, that's the stupidest idea I've ever seen in my entire career. He said, why would it be innovative to build a thing out of more unique parts? That's not innovation. He said, that's retard-a-tear. And I thought, uh-oh. That was the one I thought was the most digital. And he said innovation would be building a chair out of two parts, because he said most chairs are built out of 16 parts. So that's where the ravioli chair came from. And what I found with the ravioli chair is I spent about a year making foam molds to study the ergonomics of the chair. And I wanted to have a chair where you could sit in 2 positions, where you throw your leg over the arm and you throw your arm over the back, and you could sit sideways in it, or you could sit frontways. So I at the time, was thinking about an idea of the one and the many, where you would have one thing that would have many different positions stored in it. And I won't be too retrospective, but in Animate Form, I remembered talking about a boat hull, where a boat hull is designed so that you can sail into the wind effectively, and you can also sail with the wind behind you effectively. And all those different points of sale are stored in a surface which doesn't change its shape. And it's one surface, but it has a lot of performance stored in that surface. So I took that approach and applied it to, for instance, the Bloom House, where we decided that the Bloom House would be just 4 surfaces, the floor, the ceiling, and the 2 walls. And every piece of equipment, every piece of, like in the, say in the bathrooms, hold on, there we go. So in the bathrooms, all of the plumbing and fixtures, the sink, the mirrors, everything was swallowed into one surface, even to the point where I didn't want to buy metal pulls for the drawers and the cabinets, so that every single piece of ergonomic information was built into one surface. And that surface was just the wall surface. If you needed a sink, you folded that surface out and built a sink into it. A whole series of projects use that logic of, not having doorways, integrating everything possible into single surfaces and building as much content into a single surface as possible. So that idea of the digital bringing complexity through tectonics and numbers of parts and details, I quickly abandoned in favor of the digital having something more to do with performance and something to do with multiple types of performance all stored into one component. And frankly, it's a very conservative idea, but reducing the material, reducing the weight, and reducing the components of construction. That, frankly, digital technology was combined with double and triple curtain wall systems, and it really became associated with more stuff. And I'm really interested in the digital being associated with less stuff, like higher performance, less stuff. So, so that automatically led me into composites. And so this is now all the recent work. So a composite could be a lot of things, but when I say composites, primarily I mean fabric-based structure, so fiberglass or carbon fiber structure. And the language of those things is stiffened shells or tubes or curved panels. If you want to make a flat sheet of composite material, you're already inefficient. So curvature is usually what gives something stiffness because it's what distinguishes the shell that's in tension versus the shell that's in compression in the sandwich that you make. The other thing that's great about composites is you're doing structural design at the scale of sometimes a single fiber. Like I'll show some examples where we're actually designing not beams, but pieces of string, like dental floss, and locating all of that fiber work digitally. So the most recent example of this is I've been working with a company called Medix in Turkey. They're a family that's been weaving carpets for hundreds of years, and they now weave carbon fiber and fiberglass for the wind industry in Europe. And they have a factory now in North Carolina and one in Hungary, and they're building a new factory in Manisa, Turkey. And they asked if I would be interested in looking at the cladding, and frankly, we ended up designing the whole building. And it's really a combination of very conventional and old methods of construction with what they can do in their factory with carbon fiber. So for them, the proposition is really not just the building. It's demonstrating the possibilities of what they can do with their material. And so the building has to exhibit some of the opportunities of composite construction. And it's also nice that the headquarters building is right next to the factory, so we can get a part that's about close to 20 meters wide by, honestly, could be an infinite length. I mean, they could just keep building on the end of it as we took it out of the factory. But we could build really, really big parts. Like a part as big as maybe this entire ceiling we could probably pull off nearly in just one piece. So, the approach to it is to build these large, lightweight components. And there's two kinds of spaces in the building. You'll see the one kind of space is this poured-in-place concrete. And then you always get one or two walls of each one of the rooms, which is one of these giant composite panels that's glazed. And then you get all this kind of free plan around those individual rooms. So it's a pretty simple idea. The shells will be glazed on the ground and craned into place and hung on the concrete frame. So the shells are not rain screens. They're actually insulated structural envelopes that'll be built in these big super panels. Like I said, we'll have a poured-in-place concrete building structure, which is very affordable in Turkey. And then there's a few places where we'll have very high-strength, long-span shells that'll just get lifted right up onto the roof of the building. So, you know, that's kind of that's a model of the core of the building, just to give you a sense of those two different kinds of spaces in the plans. We're doing 47 unique panels, and the way we manufacture them is there will be 2 or 3 big blocks of foam, and we'll cut the molds for a part, open mold, laminate the part, put in a balsa core, laminate another carbon skin on it, pop that part off, and then remachine that piece of the mold down a few more inches. Almost like if you've ever had that pasta in the giant wheel of Parmesan cheese where they just keep making more pasta in the cheese till it's gone. So that's the approach we'll use to manufacturing. And just a few views of the first study model we did of the project. I have to say I had to know a fair amount about carbon fiber before ever starting this, and getting to know about the carbon fiber was really just an intuition. And talking a little bit for the student magazine about, you know, how you make decisions, I have to say I'm very quick to like jump off the cliff if I think that there's something interesting on the way down. And so one way to get to learn a lot about carbon fiber is design a foiling trimaran for yourself and build it yourself in carbon fiber. I would say it's about the quickest, maybe not the most efficient or economical way to learn, but so I decided to design this boat for myself, pretty much adopted an aerospace engineer, and the two of us worked for about 2.5 years designing this, and did a lot of interesting things along the way that ended up applying a lot to projects, architectural projects and other projects, although at the time I would have had no idea. I just knew it was worthwhile, but I didn't know how it would be worthwhile. Like if I had to come up with a business plan for this decision, that was a very tough business plan to articulate. But the reason that I had to use carbon fiber for this boat is that it needs to weigh almost nothing. Just an extra person. A studio from Sahar came to see the boat, and there were 12 people. And when 12 people, I never put 12 people on the boat. When 12 people got on the boat was like 3 inches above the water. Like they almost sunk the boat. That's how sensitive it is to weight. So it needs to be incredibly light, but it also needs to be incredibly strong. And just so you get a sense of the strength, like this beam that connects the outer hulls, the floats, to the main hull. So this beam goes from 8 layers of carbon stacked on the top and bottom walls of it to 120 layers here. And with an SUV parked on this, it has less than 1 centimeter of deflection. So it's 7 times stronger than the equivalent steel section. But you can carry it, it weighs less than 300 pounds. So 2 people can pick it up and carry it around. But it's much stronger than the equivalent I-beam you'd use to span 20 feet. The shells, it's all cored construction, meaning it has a layer of carbon and foam and then another layer of carbon. I'll show you a little bit about how it was made. So this is a mill at Bill Chrysler's shop up in American Canyon, California. And we cut these big molds in foam. This is actually recycled foam. So we cut these molds. We just plaster the molds, I mean with house plaster to fill all the voids, and then spray them with a couple of paints and release agents, and then start laminating the carbon fiber on them. So the way you would make a skin like this is you have fibers that are oriented in the 0 and 90 and the plus minus 45, and you just do 1 layer of each of those to give you kind of omnidirectional structure. And then everywhere there's a load, you start to just stack up strips of material. And the orientation of those strips is all based on finite element analysis of the structural loads. So you only put the structure where you need it. So with a steel beam, you calculate the maximum structure you need, and then you just extend the steel all the way out to the 2 ends, because you're extruding it out of a machine. It's cheaper to just waste material than it is to make it bespoke. This is the reverse. Like there's sometimes just those 2 basic layers of carbon all the way at the tips and tail of the boat, but in the middle, the stack of carbon might be 1.25 inches thick on each side of a core. So you put the structure where you need it, and that's it. The most exciting thing about it is that I have a motor, but it's like a little bass boat electric motor to just get off the dock, because the boat sails at like 35 miles an hour. So you would never put a motor on it. You always sail faster than the wind. So it's amazing to design a thing which just by the virtue of its shape goes 35 miles an hour. So the shape of the sail and the shape of the hull and the appendages, that's how it goes. So that's how it moves. There's no motor, there's no energy involved. It's just the shape. Now, correct me if I'm wrong, there is no shape in the world that generates movement that's a box. It just doesn't exist. So every piece of this thing is curved in some way, and it's the curvature that generates all the force and the motion. So how do you model a thing like that? You don't do it on grid paper. You have to do it in an environment that has physics built into the environment and an environment which is dynamic. So this will just give you a sense of the difference that shape makes and weight makes. So this is just with maybe 6 or 7 knots of wind. And you'll see, we'll go by a sailboat, like a fairly high performance sailboat, frankly, right here. But what you should really notice is this poor powerboat trying to keep up with us. So it used to be when we would go sailing, we would pick sailboats and say we're racing them and they don't know it. Now we pick powerboats. And actually, if you like to ruin somebody's day, pass a powerboat with a sailboat sometime. They really don't like that. So the way we modeled this, we worked with Cal State Long Beach mostly, and did the first coupled aero and hydrodynamic study in dynamics. And it really brought me back to like the late 80s and early 90s when we were first starting to model things in physics environments. But now, honestly, you could probably just do this in Unity. I mean, this is almost like game engine type stuff, is getting to be very similar to what was the absolute cutting edge of aerospace and nautical software. So this is just studying displacement, which is how much the boat could weigh, so how much of it needs to be in the water. We did, the coupled airflow. If you see, you kind of have to be an aerospace person to think this is a crazy image, but you get the flow lines of how the shape of the sail and the position of the mast generates force, but you also get drag and flotation and buoyancy as it moves through the water. Usually those are two totally different organizations or different people. One does the sail plan and gives you the force, and then you hand that to the person that does the buoyancy and the flow. So, and I'll talk a little bit about some of these curves and shapes and why they're the way they are. When you put this in a 3D environment and nobody's driving, something bad always happens. Because actually it is important that somebody's driving when you couple the aero and hydrodynamic forces. But what this is showing us is that we had this board placed too far back. So the principle of the boat is that as you get moving faster and faster, this foil that's in the water lifts the boat out of the water until you're pretty much free of all the drag of the water, and you can just sail on these little sticks. So this is, because of this, we moved this forward and also moved the point of effort back, meaning moving the mast backwards. So, and this was like the old days. Like this animation took 6 very powerful computers with multiprocessors each, 7 days to grind this down, and we would look at it. So it took us about 6 months to go through this process. One of the things with a boat like this is that it doesn't tip over sideways. It actually flips end over end. Like the back goes over the front and you flip over like a cartwheel. The way to avoid that happening is by having a shape like this. So this chine, this crease in the surface, makes the boat get much fatter at the top. So if you nosedive and the boat starts to go underwater bow first, all that extra buoyancy comes into play. You call it reserve buoyancy, and it then helps lift the front of the boat back up before you trip and go upside down. This is here just to keep us dry, so that as you go through a wave, the wave hits that and gets sprayed away. And I'll show you a video where you'll actually see these two shapes doing exactly what they're supposed to do. So there were good sailors in Texas, but in Austin, but I won't go into all of the reasons that happens, but the boat is always going faster than the wind. So even if the wind is behind us at, say, 10 miles an hour, the boat's going maybe 20 or 25 miles an hour, so it thinks the wind is on the front. So if you hit a wave and slow down, the wind goes from being in front of you to suddenly being behind you. And so if you go down a wave and plant the nose of the boat and stop, the wind comes around and pushes you the rest of the way over, and you flip over upside down. So all that extra volume up there has kept me a lot of times from flipping over upside down. The one other thing is when you go 30 miles an hour, drag, like air drag, is actually a problem. So like we should probably wear like Lycra suits or something, but the boat is pretty much optimized for airflow as well. So this is the first feedback we got on drag. And so all these red surfaces we had to get rid of the same way you would in a car to try to reduce the amount of air drag. Okay, so this is what it came out as. This is to show you what one of those foils looks like when it's out. So on the other side of the boat, the foil is down. But you see there's this little tip which gives you some lift. And then as you push the curved foil down, more and more of the curve goes in the water, and it's what helps lift you up as you move. Just to kind of show you like where you sit and drive. Here's a video of, I won't speak for the other 3, they're pretty good sailors, but more or less 4 amateurs, like passing a whole boatload of Olympic sailors. So it's a good argument for equipment and for design. Like it's not skill, but every race we ever do, we always win by a lot. I mean, we have a horrible handicap, so we lose. We don't ever get any trophies, but we always are the first ones at the bar. So that That's the first thing I ever designed that literally moved. And so after all these years, like with the first thing I showed you where I thought all you could really do is arrange parts in frozen space and then freeze it and then hope to make somebody's eyes happy by how they moved around the room. After designing the boat and going 35 miles an hour with design, you suddenly say, you know, there's more performance here possible with animation tools than, you know, just keeping things static. So I would say the things in terms of moving that I'm very excited about now in the last couple of years, the first is machine vision, just, you know, how architecture could start to see the things in it and start to move the things in it from the perspective of the machine, not the perspective of the person. The second is just thinking about mobility, like literally approaching buildings the same way you'd approach a city. And the third is localization, which I'll talk about. I need an example to show you that. So this is the first thing I ever designed for a machine. This was, we opened up these offices in Boston, and I got a phone call saying, Greg, you need to pick out the carpet for the offices. And I said, I just get gray bowl and carpet. And they said, well, no, there's 3 samples. So will you just pick one of the 3? And I jokingly said, just show 2 of the samples to the robots and see which ones the robots liked. So if you look at this, let me back up again. So here on the left, these dots are features that the robot saw in the pattern of the carpet. And then here on the right, you'll see the different carpet sample and how many features it picked up on that sample. So even though, for me, there was really no big difference between the 2 cool gray colored carpets, the robot liked this like 8 times more. So, so that's the carpet we picked. So we're starting to design spaces for machines now rather than people, which I think is kind of interesting. The second thing is that our eyes now are realizing all these impossible views. So for me, air drones and land drones and self-driving cars and your Roomba vacuum cleaner, I mean, these are all seeing the world in a different way, and there are cameras on all of them, and we're seeing those cameras, and I think our perspective on the built environment is being changed by the fact that we have all these eyes in all these weird places now, that we're seeing through machines all kinds of impossible views. And so, gosh, where are they? I think there is Sean and Melissa from my office flying this drone. Oh. Flying this drone. So the first thing we did was not build a 3D model, but actually fly the drone off the tower for the tower where we were making the residential proposal, and started to think completely differently about how you think about a tower on the skyline. Like it's just when you have a drone, the design of a tower completely changes the whole problem. And it actually became more about what's it look like to be in this apartment where the drone is, and what do you see in terms of Hollywood and the ocean from that apartment. It was more that than what kind of a hat do we put on our tower. So I think those views are important. The other thing is just, I've had glasses to look at virtual reality on my head now for 25, 30 years, and have always been bored by it. But augmented reality I find very exciting. The reason why is because in this example of the HoloLens, which I've done some work with HoloLens to just think about applications, the stereo cameras and the infrared range finding positions the device in a space so that it's making a map, and then it's dropping things into that map and combining virtual things with physical spaces in such a way that you really, I wouldn't say you change the way you design. I mean, this was a thing we did for Microsoft to kind of explain some of the uses of mapping virtual elements on physical models. What's incredible is, frankly, the use of it for construction. My students in Vienna, that's all we're doing now, is they're going out onto the ring and they're building giant models with just strangers. They just put HoloLenses or Tango tablets out and have a set of components and just have people that have no construction skills suddenly building these things. But it's amazing how big and how fast we can work now, that we're not building models using digital, like 3D printers and CNC mills, but actually just using augmented reality devices to assemble things. Yeah, so anyway, the other aspect of this localization is there's a need for new landmarks. This is not maybe the most exciting example, but it's definitely a case where literally Jaron Waldman came to my office and he said, I've got a company that does work at the intersection of the digital and the physical. It was the first time I'd ever heard that phrase. And he said, I need physical landmarks. Would you be interested in designing the physical presence for all of the things my company does? And I said, yeah, sounds interesting. And so what this company, Curbside, does is their idea was to turn shopping malls into Amazon fulfillment centers. So you would order things on the Curbside app. It would tell you where that stuff was. Like if you said, I want a scented candle and a dog leash, it would say, okay, I can get you that at Target or I can get you that at the mall. Take your pick. And you'd pick one of those two and you'd order it, and then they'd send you a note back or send you a SMS message back at a certain point saying it's ready for pickup. And what you would do is, order, get notified when it was ready, and then walk, ride a bike, or drive your car to the location and just pick your stuff up. So instead of having the stuff delivered when you're not home, that was their plan. They now do this for Starbucks when you order your coffee, for H-E-B when you get your groceries and it says powered by Curbside, that's these people. So what they needed was, at the pickup places, they needed some physical landmark. And they also had the problem where they might have 3 or 4 of these in one location. You needed to tell which one to go to. And what's common to all these things is they have very high capacity antennas in the top of each one, which allows them to know within a few centimeters where you are without draining your telephone. So they would not want me to tell you how they do that, but they, they have a whole layer of things they turn on your phone when you get close to your bag, so that by the time you're within a mile of your bag, they have everything lit up on your phone, but then once you leave a mile, they shut it all down again, so they don't drain your phone. That was the biggest problem they had. So what happens is, they'll dispatch a picker into the mall or into the Target, and they go in and they pick the stuff. They then put it in a bag in the mall or in the Target, and then when you get close, it gets moved out to these pickup pods, and then as you pull up, they ask you if you want to have it in the car or have it in the trunk. So at the Glendale Galleria, where we built this pickup pod, they said, well, traffic and planning is going to need a traffic study to tell us the impact you're going to have on parking and waiting times for this particular site. So I said, okay, here we go. So I called 2 lawyers, I got their proposal, I got the schedule for the study, I pulled it all together, and I sent it to Jaron about less than a week later. He said, oh, we have all that data already. And I said, what? He said, oh yeah, we just had every Curbside employee in North America record how long it took from the time the car stopped to when it left, and the average time is 13-point-something seconds. And here's, 100,000 examples of it in the last week for you to give to the traffic planner. And we just walked in with the digital data. The traffic planner said, gee, that's amazing, okay. So it's a new world. That's one thing I would say, is that the risk-averse, do the study the same old way approach of architects is so out of sync with the way the world of technology moves and technology startup moves. It was a wake-up call. So anyway, and we had to build these things and set them up in less than a day. So those are all carbon fiber and fiberglass. They're 100% composite manufactured, and there's a mold, and it takes about a day to lay up one of them, and it actually takes 2 days to gel coat them and paint them. It takes longer to finish them than it does to make them. And it comes in a flatbed truck, and with a little, very small crane, you can set the whole thing up in an afternoon. So it's also, in terms of construction, very different, different paradigm. And I'll also say, I think just for the students, these people, Curbside didn't have, I mean, I don't know what you think it's worth to have me design your physical identity, but I had a pretty good idea, and it was about 3 times what I knew they could afford to pay. So they paid me enough so that I could pay everybody, and then I got the extra with a multiplier of 3 in equity in the company. And now this is like, you know, owned by Rakuten, along with the Barca Football Club and the Golden State Warriors. It's like it's a good thing to take risks. It's the 4th time I've done that, and the first 3 times I got washed out in acquisitions. But, you know, the venture world says 1 out of 10, so I'm 1 out of 4. But it's a good thing to also think about new ways of doing business, frankly. So because of Curbside, I was asked to do a little design for a micro house for the Interior Festival in Kortrijk, Belgium. And so here we had this idea to do a really small house with a lot of living surface. And we did 1/5 mock-up. So this is like the small model of it. But the idea is that you roll the house and the furniture disappears into the house, like on an old-time boat. So like that's your nightstand with all your stuff on it, but it's sitting with a lamp on the bottom of it. That's your bed. All of these surfaces disappear and pocket into the walls until you roll the whole house, and then the stuff that was in the wall unrolls and becomes something you can occupy. So the big trick was making the robot to roll the house around. So we made this 1/5 scale robot that would roll the house, and we also built a little app for everybody that visited so they could download the app and drive the house. So that's with just TouchOSC. So this was the first time I'd ever, within the office, like built a machine and programmed it digitally. And so we started just putting this on everything. So we put stepper motors on a table and made an interface so we could drive the table around with a phone. And I had an idea that all the furniture in my office already had wheels, but I thought it should all drive around, and it should learn where it is, and then it should start making decisions about where to go based on where it had been. So if every Tuesday we were always pushing the table away, then Tuesday the table should just drive away at 11 o'clock in the morning. And, and that way we'd have this other relationship with the built environment, where the built environment would be watching us, and it would start doing things that would provoke us, and then we would do other things, and pretty soon you're in a totally different relationship with your stuff. So I went to 3 furniture companies and asked them if they would like to start to do this with their furniture. And all of them said, we know we're going to need to do it. We really don't want to do it. If we do it, we want to do it with you, so tell us when the other people do it, and then we'll start. So, and then these are like furniture companies that I thought were already doing this, frankly. So anyway, that is the genesis of the JITA, was that conversation. I'll get to that in a second. The other thing I thought I'd talk about is technology, which is close to the body and ergonomic, like the ravioli chair a little bit, but that isn't just about shape, but is also about electrical systems and environmental systems. So Nike came to me about developing a chair for the NBA, and the one thing that's amazing about Nike, and actually just amazing about sport, including the boat, is it's a change in paradigm. Like, instead of boats float, boats fly. Okay, so that's the paradigm that led to the trimaran. But in order to get the boat to fly, you have to break down every single part of the boat into its absolute smallest problem statement and then solve all those problems in a new way in very, very small increments. And you're fighting for every single ounce or every fiber you can save, you're fighting. And I'm really sorry, but that's how the world works now. Like, you have to have a new idea that's a big idea, but you don't solve it with a big solution. You solve it with thousands of tiny incremental solutions. So Nike is really good. That's their language. So we got along really great. While we were working on it, they did this thing which just is amazing to me. I'm not a runner, but they just decided, look, let's break the 2-hour marathon. Like, the record is like 3 hours. Let's just shave like an entire hour off of a marathon. So they grabbed the 3 fastest runners in the world, and they broke the problem down and solved every single part of how to do an ultra-fast marathon. And in a year and a half, went to the Monza racetrack at the perfect day with the perfect temperature, with the perfect wind, and set a 2-hour and 25-second marathon. The one thing they didn't think of is that they needed a crowd. So when Kipchoge finished, they said, how could we have gotten just 25 more seconds? And he said, you know, there was nobody cheering at the end. I'm sure if there was somebody cheering, I would have run faster at the very end. But they break the problem down into small increments. So this was the problem, is how do you get LeBron James to do that in the first 2 minutes of a basketball game before he gets warmed up? So basketball players warm up, then they sit, then they stand, they don't kneel, they stand for the national anthem or whatever it is, and then they start playing. And in that just minute and a half or 2 minutes, they get cold. And so you'll never see a professional basketball player dunk a ball in the first 2 minutes of the first or the third quarter. But imagine if you're the team without the secret chair, playing the team with the secret chairs, and for the first 2 minutes, they're running full speed and dunking on you. That's the whole game. So, I mean, you lose. So we built a chair called the microclimate chair we actually pulled a lot of data off the players that we found out was irrelevant. The more players we talked to, they just said, just make it hotter, just hotter. Like, no cold, don't care about weight, don't care about moisture, just make it hot. So, but it's a chair that has Peltier chips that can both heat and cool, depending on how you put a current through them, and each one of those is individually addressable, and all kinds of weight sensors. Then the big question was how to get the players so they're not like D'Angelo Russell here with his head back, like falling asleep in the middle of the game. So we had to get the posture right, but we wanted to get the player swallowed up in the chair as much as possible, because the more surface area we could have on them, the better they were captured. They refused to get in and out of this chair on public, on broadcast television. So even though this is the best one, they're like, I'm not going to get in and out of that thing on TV. So anyway, we went through like tons of them. Unfortunately, you can't get elite basketball players to come to weekly meetings. So we used a lot of AR scans of players and in posture to test it against things we were doing with the shape. And honestly, like centimeter decisions were really huge. Like we spent about a year just fighting for centimeters here and there. But so that's kind of that's one of the prototypes that's naked in terms of all of the components. But it was really like an electrical engineering and computer programming project as much as it was a design project. But it all comes together. I mean, it's important that it all comes together. So, and that's, I shouldn't leave that up for long, but that's with the Flynet top and the back. It's changed a lot from there. Okay, so hopefully all that stuff is weird enough, and then the really weird stuff happened, which is I got involved in urban planning and mobility. And so 3 years ago, November 1st, we started a company called Piaggio Fast Forward with the company Piaggio that makes Vespa scooters and Aprilia motorcycles. And they said they wanted to rethink what lightweight mobility would be in North American cities. And so they actually very brilliantly said, let's start with Mumbai. This is Hanoi. But the reason you don't own a car in Hanoi is because you couldn't drive it. I mean, you're going to see like a couple cars in here. We counted in 1 minute, there are about 150 mopeds or scooters. There's a couple dozen bicycles, and there's a couple dozen pedestrians, and 5 cars. So if you took each one of these people and put them in a car, it's a parking lot. So it's not that you need to get technology to Hanoi and teach Hanoi how to work. It's that you have to understand that 20 years from now, Austin is going to be Hanoi. And you have to figure out how to accommodate the fact that Austin is going to be Hanoi. And the really bad news, and I hope there's nobody working on self-driving cars here, they're making it worse. So ride sharing is adding 20% more cars owned in Manhattan, for example. It's got more cars sitting around idling, waiting to pick up rides. All of the strategies to make it better for traffic are actually going to make it a lot worse. They're already making it a lot worse. So we're trying to do something which is a very simple idea, frankly, which is make things lighter weight. So this is Market Street in San Francisco about 12 years ago. So notice how fast everything's moving. So just because you're in a car doesn't mean you're going fast. And notice how much of the space is taken up with the cars. And then this is probably a video a lot of people have seen. Look at exactly the same strip of Market Street in 1906. And look at how fast things are moving and how many things are getting moved. What's great about 1906 is this is at that point where one regime of transportation was being infiltrated by a totally other mode of transportation. So you had 2 mobility paradigms existing at the same time in the same street. So you have horse-drawn carriages, you've got automobiles, you've got streetcars, you've got bicycles, and you've got pedestrians, all in the same space. I mean, the only thing that's on rails is the train. Everything else is a free-for-all, a lot like Hanoi. So this is our vision of the future, more or less. We want to get back to this. and I think in Austin, you're seeing it. I mean, when you bring in the electric bike shares, when you bring in the scooters, when you bring in all that stuff, you're talking about multiple mobility regimes competing for the same space to solve the problem of mobility and congestion. Okay, so yeah, maybe I'll play this thing. This is what we started with.
And people, we want to understand which are the new needs of young generations.
Because we come from Piaggio.
Can you turn that up a little bit?
We see cities in a different way than an automobile company. We think about people moving in a granular way.
Granular mobility is a concept that we have elaborated within Piaggio Fast Forward to call attention to those spaces that we navigate as pedestrians, as citizens of the 21st century city.
We thought, let's try to make a product which engages all those different cities and the way people move in all those cities.
JITA was designed to leverage the power of human navigators of urban spaces to make sense of them. We imagine it as a kind of Vespa for the 21st century.
JITA is thought to help the human, from a young kid in the school to an older one in a hospital, for instance. It's a total fusion of the 2 technology.
It's a land drone, it's a cargo bot, it's a Sherpa, and it's a smart device that learns the environments and maps them as it travels them with human guidance.
It moves as slowly and can maneuver the same as a human.
Okay, so you get the idea. But so from those first ideas about building a device that would map and move through the world on its own without positioning, is really where we started the company. And the The idea is just very simple, that instead of getting in your car to carry a couple gallons of milk for a half a mile, or because you want to bring your athletic equipment to the soccer field, or because you want to bring your kids' stuff to school, that you could actually walk. And so we've been looking at American cities and American transportation and finding out all kinds of amazing facts about how to help people be pedestrian, but how to make a piece of technology that doesn't solve pain points, which is a term I hate, but actually helps people be more connected to their neighborhoods and more active and more social. So, and in this video, I don't know if you noticed, but there's taxi cabs, there's ride shares, there's an electric bike, there was a bike share stand, there's a bird scooter. So there's, you know, we want to be part of that mobility revolution, but instead of owning the bike path in the street, we want to be the sidewalk. Okay, so these are the things we've noticed. People live, work, and play within 15 minutes. That's the ideal place. That's why Austin has however many people move in every day, is because everything's close enough, you can be in a neighborhood. That's like a given now if you want to have a city that grows. Techlash is just too many people are on their phones all the time, and when you go out with your friends, a lot of times you'll just all sit on the phone together. So the response to how much time we spend in front of screens is making people want to have different kinds of experiences that aren't screen-based. And then finally, the power of the outdoors. People want to spend their leisure time being outside. When we did a little bit of research, we found in the US, 20% of driving trips are less than a mile. And those are within your neighborhood. We also found out 10% of all trips right now are walking trips, which is 10 times more than bicycle trips. We thought people commuted by walking. Nobody commutes by walking. Most people walk because they like to walk. Like 80% of Americans, when you ask them what's your favorite mode of transportation, they say walking. Like before a bus, before a car, before a bicycle, people like to walk outside. And, you know, close to 60% of the people walk just for pleasure. Like they say, it's a more pleasurable way to go do my shopping, so I'm going to walk instead of driving because I like to walk outside. 50% of people walk for errands. So this is the place we want to be focusing on, not automotive. So we're doing autonomy, like a car would do autonomy. But you'll hear a lot of people say, well, is a robot going to replace me? And they'll say, well, it's only going to replace those things you don't like to do. So instead, we want to have robots help us do more of what we like rather than replace all those people that we don't like them doing what they're doing. So we're not like a delivery robot. Like you don't order a burrito on your couch and have it fire the burrito through your window at you. You know, you get your butt off the couch and go walk over to the burrito master and have a relationship with the person making your burrito. So, and I won't go into it, but we're teaching them a lot of pedestrian etiquette. So our version of autonomy, our 5 levels of autonomy, is first just following. The second is paired autonomy, meaning if you turn a corner or move in a crowd, it can infer where you are and follow you through a crowd. Smart behaviors is that you can hold a door for it and it'll know how to go through a door. It'll do all kinds of things that we don't think of as behaviors but exist. And then when it does something on its own, it'll do it on a route where we teach it. So we can maybe send it somewhere that it's already been taught. So the way it works, and this is just to show you, like the girl in the blue hat is who it's following. And you'll see all the other kids are trying to steal it. So, and I'll show you, that's just an example of how it sees the world. It's not like following something in her pocket or something. It's actually doing some very complex analysis. So this is how it sees the world. So anything with 2 blobs that move like legs, it puts a box on and calls that a person. And when it's in a room, it makes a map of all the people in the room, And then the things that are light blue are all the objects that are in the room, like pieces of furniture or walls. And it'll do path planning based on following the person among the people and making sure to path plan not to hit obstacles. So it's visually doing that in the environment. We also are doing some machine learning where we're teaching it to follow, you know, people that have 2 legs and 2 crutches, for example, or how to follow a wheelchair, or also how to follow, every morning I go for like a 20-minute walk with usually this one, and this one's been taught how to follow a dog. So that's my dog, Harvey. And so if you look closely, you'll see it's actually following Harvey. It's not following Naomi. So, and that's really good for a person that has sight challenges, because it's better that it follow the guide dog than it is that it follows them. So, and we're doing that through machine learning, which just means we buy tens of thousands of pictures of dogs, put dogs at daylight, dogs at night, dogs next to glass, dogs in the water, all kinds of pictures of dogs, and then we teach the machine what a dog looks like, and then voila, next day it follows dogs. We even taught them to follow each other. So, but it's doing all of this with sight. Everything is visually based. So, and just as proof, this is Vince Snyder. So that's proof of life. That's from yesterday. Okay. And then just really quick, this is so this one that's here, it's called a gita, which means short trip in Italian. This is the new version of it, which has much more control authority, because you'll see, for instance, it moves over top of the wheels. So the more weight you put in it, actually the more stable it gets. And it has a very different form factor. We managed to make it smaller, quite a bit, like 20% smaller in footprint, but also it carries a lot more stuff. Carries, you know, a third more volume, actually. So, because this is one of those things, it's actually just like somebody's building. You ask everybody, they say, well, I really want a huge amount of cargo capacity, but it has to be really small. So we tried to be as efficient as we could with the footprint of it. And this is just kind of some of the use cases for how it might get used. And this is at Reebok's headquarters, but we found this on the wall, which is really great, which is a life in motion is the only way to find our best selves and to be more human. So really what we want to do is make, it's very counterintuitive, but a very high-tech robot that helps us be more human. And then the last thing I'll say is, you know, that's the mayor of Miami Beach. I would say a third of what I do is go around to legislators and make sure that they understand that this is a thing which is always with a person, that it's never alone, it's not autonomous, it's not taking somebody's job, it's actually helping people not drive but be more pedestrian. And so in this state of Florida, we have legislation for ourselves. Texas will probably be next. Utah is coming. We're going state by state and making sure we get legislation that lets people understand that not all technology needs to be like city killers and job killers, and that this isn't going to be a whole bunch of autonomous robots driving around the sidewalk by themselves, but this could be more people walking around doing stuff in the city. So, thanks. Of course. Yeah, of course.
Hey, is this on? Hello. Okay. So I think that this is, spectacular, like earth-changing work, and I really like that you've considered the implications of somebody like a wheelchair user using the JITA. I wonder if you could elaborate a little bit on the implications of a design product like this for people with disabilities.
Sure. I mean, we really think we want to try to do something which is very, let's say, as broad spectrum as possible. And I think doing something that's broad spectrum doesn't mean that you have to decide on the median, but you actually just try to have as much scope as possible. So when we've been piloting with these, which means just taking devices like this and just giving it to different people, really that's what we've been doing, is we'll just say with the Los Angeles Veterans Administration, we gave them JITAs for a while, we interviewed hundreds of veterans, we found out how they move and where they move, and did the same thing with people with prosthetics. Like it's very, just a little bit of being off balance, like carrying a backpack can be really tough if you've got a prosthetic leg. So having something that follows you gives you much more mobility. So really just learning, I would say, and piloting with as broad a spectrum of people as possible is how we decide what the performance specifications of it are. And the fact that it's an electronic device, a lot of that is pretty tunable. Like, we're not there yet, but if we need to, we can have settings on it where the following distance and the speed and all those things are set for that. Frankly, this one, moves like a senior, because it's an early one. And so what we found is this one, tons of seniors are like, just sign us up. Like, we have tons of money, we have lobbyists, we're going to get these things, come to Florida, and there was a huge market pull for people with mobility disabilities, like bad backs, replacement hips, stuff like that. Then when we got the faster ones, then suddenly Nike is saying, how about one for runners? How about one for trainers? So a lot of it is just getting the device so that it's got enough of a spectrum that it can work for a bunch of people. But we don't really see it. We don't see like a market. The real limit for it is, frankly, the cost. And the price is much less than you would think. I can't say what it is, but it's less than you think. But it's still what you'd call like a considered purchase, like a cell phone. Like, how long does it take you before you upgrade your cell phone? That's a considered purchase, and this will be a considered purchase. So. But I also think the people that are not hopping on a bird scooter in Austin right now, we definitely want to be an alternative to that, because the average bird ride is less than a mile. So it's more or less in place of walking. So for the people that are not ready to get on a bird, we want to give them a way to get around walking, but without having to carry all their stuff.
So I understand it's really helpful for people who need that ADA help, and so they won't be taking stairs and more difficult terrain, but as a runner, I often go off the beaten path and I'm on stairs and I'm running pretty fast down uneven trails. How do you plan to navigate that if you're trying to reach that market?
Yep. So ones like this, we had following bikes even. Like, this will go 20 miles an hour, and it'll brake about the same as a bicycle, but it needs about $10,000 or $12,000 of LiDAR and processing power and battery life to be able to do that 20-mile-an-hour thing. If it was a car, it would need more like $30,000 of stuff to do that. So if you're willing to pay 400% to 600% more to run, then yes. But we're counting on technology getting a little bit ahead, because right now the compute power in the world it's still getting better, but it's not Moore's law anymore. It's not exponentially getting better, but sensor technology is. So this one has cameras that are really like the cameras on your cell phone. Like, the whole sensor pack on this is maybe $100. So the sensor pack on this is more like $7,000 or $8,000. So But that's why we can only go about 6 miles an hour, is really because of how it sees. It's not so much, like the vehicle dynamics of this one are done by the people that do Aprilia racing motorcycles. So and we have a couple tall ones, like we think there's probably one that we'll do for campers first before runners, but one that can kind of go on trails and things. You know, we've never even thought about weaponizing one. But no, it's, I think, I mean, with the vets, we actually have a really great conversation, and the vets are, I mean, you can't generalize, but the contact we've had is really great because the people we've talked to are very technology forward, very, you know, smart about machines, you know, very willing to try new stuff, and like huge amount of walking. Like, you know, a lot of vets are walkers, and especially somebody that has PTSD, the first thing you hear is they don't like to be in a closed car or a bus. And so we've talked to people that walk, you know, huge amounts just because they're not comfortable in vehicles. So we do a ton of testing with veterans, and actually have a bunch of veterans even in the company. So that we're in. But I think military, I don't even know how you do that. And the lead time is really long. Like we're from 0 to here in about 1.5 years, and then with this in 3 years. Whereas if we were doing defense contract work, that's like 10-year cycles. You get well funded, but we're not like a startup or a think tank. We actually want to make stuff that gets out in the world quick.
This is a brand new human-computer interaction. I mean, we're not used to having robots following us, at least that we know of. So I'm curious what you learned in user research about how, were there any surprises about how close it should be to people, or how people reacted as it was following them?
So I'll come back in 1 year. I wish I could tell you. The most exciting thing we're doing is not that, it's that. But I can't talk about it. It's the most valuable thing in the company we're doing is all of the pedestrian etiquette. Like how far it is and where it is, and we do tons of, and you know it, for 2,000 years we've been moving with stuff. And really all you have to do is just think a little bit about that and figure out how to encode it. But yeah, that's what we're doing that nobody else is doing. Most people just put some googly eyes and a thing that makes it smile, and they think that's interaction design. So no, we do like deep 2,000-year-old comfort studies about how you move with stuff. Well, it's nowhere near what you're thinking it costs, first of all. But so if we were to lend this to you, I can say with pretty much certainty, you're going to call somebody and you're going to say, I have this thing. Let's go do something. So, which all I mean is that it's not like me and my robot. It's really a very socializing tool. It's more like, you know, hey, Mom, I've got this thing. Why don't you throw a casserole in it, and we'll go walk over to your neighbors? Or, you know, hey, you know, classmate, let's go this weekend, you know, out to the lake with it and bring a picnic. I mean, what we're seeing is that when we lend it to somebody, it's not just that they average 1.7 miles per trip of like all the thousands of people that have done it. That's the average. But it's also, there's always more than one person. You know, it's more than 2 people on average that take it. So it's a very socializing tool. So you're right, if it's like a tech bro thing,
then yeah, then it's got that problem. But it's really not a tech bro thing. You know, and frankly, it's just the bros, that gender doesn't get it the same way. People that carry more stuff, that are responsible for schlepping more stuff, immediately get the proposition. It's amazing when you go to the farmer's market. You know, well, a lot of women are saying, how much will it hold, how much does it cost, and when can I buy it? A lot of men are saying, what's the battery life? What's the car, you know, how much does it weigh? How do I get it up a step? You know, it's like it's a totally different sensibility, but it's really more of a socializing tool than it is like a me and my accessory. We hope. We'll see. We'll definitely see. I don't want to make it sound creepy, but 16 cameras, GPS, an LTE phone that calls the police. No, it would be like the worst thing you could ever steal. It would be like stealing some, like, you know, somebody's ankle bracelet or a low jack. No, there's pretty much nothing. I mean, the fact that somebody's responsible for it, we don't want people feeling too responsible. Like with even this one, I feel very responsible for it. I'm always listening to make sure it's following. But because it's with somebody, it would be like somebody stealing a bag, like your backpack. So, I mean, in terms of it being connected to a person. But if you like left it outside a store when you walked into a store, it's all locked up and somebody could pick it up and walk off with it. But you would know, and they would just be a very bad thing to steal. Much worse than a car, frankly. I mean, a car has probably less location technology than this does. For damage to it or for liability? Yeah, so, I mean, in terms of like dents and scratches and things, you know, we could replace panels. So I don't really think you'd bother to insure it. It's not, I guess if you'd insure a phone or like, you know, you might insure a device like this. I don't really think that it'll be that big a deal. I think what's more important is that we want to make sure there's not a lot of barriers to ownership. So that's why I was at the Capitol today, is to just make sure we don't have to put like a license plate on it. Because if we put a license plate on it, that means you got to go to the DMV. If you have to go to the DMV, you're going to be like, eh. So.
Anyway, I hope everyone here was as inspired by what Greg had to show us as I was, and we need to give him a really big hand.
Thanks. Thanks for having me.